Welcome everyone. This is the third video for our subject Physical Science. Today, this episode will be about Activity Sheet Quarter 2, MELC 9, Week 4, Wavelike Properties of Electrons. There were requests to explain problem number 2, so I will do it together with problem number 3. So here is our problem number 2. What is the de Broglie's wavelength of an electron traveling at 2% the speed of light? Looking at the problem, there are no values that we can write under the given. But further analysis, you will see that the electron is being the particle referred with wavelength and speed. And so, electron has a mass, which is equal to 9.11 times 10 to the negative 31 kilogram. So that will be our m. And then this electron is traveling at 2% the speed of light. So that will be our velocity. And then the Planck's constant. What is required? From the problem it says, what is the de Broglie's wavelength? So that is the required. Lambda. What is the equation? Lambda is equal to the Planck's constant divided by the mass times the velocity. Solving for the velocity, we need to convert 2% to decimals. So 2% divided by 100 is equal to 0.02. And then we will multiply that to the speed of light. The answer is 6 times 10 to the 6 meters per second. That is the value that we will use in the solution. Now, we will substitute the given to the formula. So, lambda is equal to the Planck's constant divided by the mass, which multiplied by the velocity. Okay, it's here. We copy the Planck's constant in the numerator, and we will multiply the coefficient 9.11 times 6. The answer is 54.66. And when we multiply numbers with exponents, the exponents are added. So, minus 31 plus 6, that would be minus 25. And then we divide. This is equal to 0.121 times 10 to the minus 9. Now, why is it minus 9? The exponent. When numbers with exponents are divided, the exponents are subtracted. So that is minus 34 minus 25. In subtraction, we change the sign here. Okay, so that becomes positive 25. So, we proceed to addition. Minus 34 plus 25 is minus 9. The negative sign here comes from minus 34. Okay, now, this answer here looks different from this answer in your module, but the value is the same. So let me show you why the value is the same. We need to move the decimal point because we need to follow the rule in writing scientific notation. It says, when expressing numbers in scientific notation, there should be one non-zero digit on the left of the decimal point. So we need to move this decimal point in between 1 and 2. And then for numbers with negative exponents, moving the decimal point to the left decreases the exponent, but moving the decimal point to the right increases the exponent. So we are moving the decimal point to the right by 1 place, so the exponent will also increase by 1. So it will become 1.21 times 10 to the minus 10, which is equal to the highlighted answer in your module. And this value is also equal to the diameter of a hydrogen atom. Okay, now let's go to problem number 3. An electron wave making a standing wave in a hydrogen atom has a wavelength of 8.33 times 10 to the negative 11 meters. If the mass of the electron is 9.11 times 10 to the minus 31 or negative 31 kilograms, what is the velocity of the electron according to the Broglie's equation? Okay, we will analyze the problem and identify the given. So the first thing we have to write is the Planck's constant. Next, it says here the atom has a wavelength, which is 8.33 times 10 to the negative 11 meters. So wavelength has a symbol of lambda. And then the mass of the electron is this. So we write the mass here, which is equal to 9.11 times 10 to the negative 31 kilograms. What is the required? So it says here, what is the velocity? So that means the required quantity is velocity. The equation, the general equation is lambda is equal to the Planck's constant divided by the mass times velocity. But to avoid confusion, we will write the required quantity on the left side of the equation. So V is required quantity. So we will rearrange the equation by cross multiplying. So lambda here, cross multiplying with 2 mass and velocity. Lambda times mass times velocity. And the Planck's constant on the other side is multiplied across or cross multiplied, but there is none. There's only lambda over 1. So the Planck's constant will remain as is. So it will be written in the numerator, and then the velocity here on the other side of the equation, and the quantities together with the velocity will be placed on the denominator. So we have now the equation for velocity. So we now go to the solution. So we will substitute the given to the formula here, or this formula. Okay? So velocity is equal to the Planck's constant divided by the mass times lambda, or the wavelength. Okay? Further, the next step would be copy the Planck's constant and the numerator, or on the numerator, and then we will multiply the coefficients here. 9.11 times 8.33. The answer is 75.88. Now, times 10 to the negative 42. Again, remember, when numbers with exponents are multiplied, the exponents are added. So minus 31 plus minus 11 is minus 42. And then here, 7.59 times 10 to the minus 41. We will convert this to that value. So remember, we need to have one non-zero digit on the left of the decimal point. So we move the decimal point to the left. And remember that when you move the decimal point to the left and for numbers with negative exponent, the exponent decreases. So we are moving it to the left one place, 7.588 times 10. This will decrease by 1 minus 41. And then we will drop this, round off the number. The 8 is 5 or more. When you drop it 5 or more, you will have to add 1 to the last remaining digit. So that is why it would be 7.59 times 10 to the negative 41. Okay. Dividing this coefficient 6.63 with 7.59 is equal to 0.8735 times 10 to the 7 meters per second. Now, why it is again positive 7? Because when numbers with exponents are divided, the exponents are subtracted. So, again, minus 34 minus 41. Remember that we changed the sign of the 41 to positive and proceed to addition. So that means minus 34 plus 41. The answer is plus 7. That is why it is 0.8735 times 10 to the 7. But this value is different from the answer in your module. Even though it looks different, but the value is the same. So we need to move the decimal point again. So 0, the decimal point here, 0.8, we will move the decimal point in between 8 and 7. So that will become 8.735 times 10. But for numbers with positive exponents, moving the decimal point to the right decreases the exponent. That means it is times 10 to the 6. 8.735 times 10 to the 6. But again, we need to drop this last number, and because it is 5 or more, we need to add 1 to the last remaining digit. So it will become 8.74 times 10 to the times 10 to the 7 meters per second, which is times it is equal to 8.74 times 10 to the 6 meters per second, which is the same with the answer, highlighted answer in your module. Now, why do we need to drop the number? It depends on the significant figures here. Okay, we have 3 significant figures. We have another 3 significant figures. So the least significant figure is 3. So that is why we need to round off the answer into 3 significant figures. That is why it is 8.74 times 10 to the 6 meters per second. Okay, I hope you understand better the de Broglie's wavelength after watching this video. If you find this video helpful, Please like and subscribe. Thank you for watching.